This video is for task 2.2. Make sure this title goes at the top of your paper and make sure you have the description of the task. And in this video we're going to answer how do you solve a inequality in two variables. And I probably shouldn't say in, I prefer to say with two variables. So go ahead and change that. How do you solve an inequality with two variables? Here's a reminder of how your notes should be set up to take notes from this video. Help. Let's go over this example. Please help me. I have $7.50 to spend on vegetables at the grocery store. Broccoli costs $1.25 per bunch, and carrots cost 75 cents per package. What are some combinations of vegetables that I can buy? If you could think of an inequality for this situation, that would be great. If not, I just want you to play with some numbers. Think of some combinations of broccoli and carrots that I can purchase with only $7.50 that I have at the grocery store. Bring your work to class and we'll discuss this word problem together. Let's review some inequality symbols. Let's look at the word less than or equal to. Less than or equal to, what inequality is that? Well, if you read left to right, less than or equal to will be pointing to the left, and since we have the or equal to part, it's going to have the bar underneath it. Okay, well, what about this second sign here? What does this sign represent? Well, if we look at the red, we notice that it's pointing the same way, it's just going to be missing the bar. And so the words for this symbol is going to be less than. And because we don't have the bar, we don't need the equal to part. Okay, greater than or equal to. The symbol for greater than or equal to will go pointing to the right. And it has a bar underneath it since it has the or equal to part. I can underline that. That's a good idea. Or equal to part. And for the last symbol here, notice it's pointing in the same direction to the right. So this is going to be the greater than inequality symbol. And it's not going to have the equal to part since there's no bar underneath the inequality symbol. So you're going to need to remember these terms and be able to read them and use them for solving inequalities. Here's an example that you may encounter. Tell whether the ordered pair is a solution of the inequality. The ordered pair that we have is 4, 5. X will equal 4. Y equals 5. And we're given the inequality y is greater than or equal to 3x plus 2. So I'm going to substitute in the 4 for x and the y for 5 and see if it's a true or false statement. And that will tell me if it's a solution or not of the inequality. So 5 goes in for y, 3x is substituted in for 4 is substituted in for x plus 2. 5 is greater than or equal to 3 times 4 is 12 plus 2 will give us 14. Now is 5 greater than or equal to 14? This is what we call a false statement. And because it's a false statement, it is not a solution. So the point 4, 5 will not be a solution for the inequality. This skill and knowing how to tell whether the ordered pair is a solution of the inequality will come in handy when we're solving the inequalities for the next couple of examples. Here are the steps to graph linear equations. And when we say graph, we really mean solve. In order to solve a linear equation, you have to graph. And it gives you all the many solutions instead of having to label them out. So here are the 3 easy steps. 1, graph the inequality in slope-intercept form. So we're going to have y, an inequality symbol in the box, mx plus b. Notice the y is isolated. We need to have it in slope-intercept form. We're going to have to use a solid or dotted line. And we're going to go over when to use a solid and when to use the dotted line. But let's do that now. If you have a bar underneath the inequality symbol, you're going to have a solid line that you need to graph. And if you have an inequality that does not have a bar underneath it, you are going to use a dotted line. So before, when we graph lines, you didn't have to worry about solid or dotted lines, but because we're using inequalities, you do. And the third thing you're going to do is check a point. to know which side to shade. I'll go ahead and demonstrate these 3 steps for you in the next 2 examples. Okay, here's our example 1. We have y less than or equal to 2x minus 3. I have a piece of chalkboard here to write down some important information. First, we need to know what our slope is. Our slope is always next to x, so it's going to be 2. And since we want to do rise over 1, we need to make it into a fraction. Our y-intercept, the point that we always begin with, is negative 3. And because I have a bar underneath my inequality symbol, I'm going to want to use a solid line to graph. So I'm going to start at negative 3 and make my first dot. And I'm going to go up 2, 1, 2, and over 1. And I can also go up 2 and over 1 again to get a third point. And I'm going to use a solid line to connect the point. Now that's what we learned in chapter 5. That's regular graphing a line. But because we have an inequality symbol here, we're now going to have to shade a side. So in order to do that, I need to test a point. The easiest and best point to test is going to be 0, 0. And I choose 0, 0 as long as this black line does not land on that point. And you can choose any point to test, but I'm going to go ahead and choose 0, 0. So that means I'm going to plug in 0 for x and 0 for y and see if I get a true or false solution. And this is called testing a point. So I'll put in 0. Then we have less than or equal to 0 for x. So the 2 is going to go away and I'll get negative 3. So is 0 less than negative 3? No, it isn't. Since negative 3 is farther to the negative side, 0 is not greater than negative 3, which means I do not want to shade the side with the red dot. I'm going to now shade the opposite side. And that's only because I got a false solution. So I'm going to shade the side because this is a false solution here. So I can't include that red point. It doesn't give me a true solution. And I shade the other side. And now that is my answer. So any point on the shaded side is going to be a solution to the inequality, any point. And instead of representing all these answers one by coordinate points, we can just demonstrate them with the graph. So remember, all these red dots that I'm making, they all represent the solution. And in any dot over here on the other side, these are non-solution, including the 0, 0. It's not a solution to the inequality. Here's example number 2. We are going to need to solve the inequality 5x plus 2y is greater than negative 8. Before I begin writing down necessary information to use for my inequality to solve it and graph it, I need to get it in graphing formation. Right now it's in standard form. So to get it in graphing formation, I'll need to first subtract 5x to both sides. Remember, we want to get the y term alone. 5x cancels, so I get 2y is greater than negative 5x minus 8. And divide everything by 2. 2 and 2. That cancels out the 1, and I get y greater than negative 5 over 2x. Remember, I want that to be a fraction because it's my slope. Minus 8 divided by 2 is 4. Okay, now that it's in graphing formation, I can identify my slope. Slope is negative 5 over 2. My y-intercept, the first point that I plot, is negative 4. And because I have no bar underneath my inequality symbol, I'm going to use a dotted line to graph. My first point is negative 4, and I always start on the y-axis. And I need to go down 5 and over 2. But if I do that, I'm going to end up going off my graph. So I'm going to go the opposite, and I will go up 5 and over negative 2. So up 1, 2, 3, 4, 5. And over to the negative side 2 more, 1, 2. And I can make my first point. Let's see if we can go over one more. 1, 2, 3, 4. Let's estimate 5 and then over 1, 2. And remember, I don't have a bar underneath my inequality symbol, so I need to use that dotted line. And if you made a mistake, you can always draw an arrow and say, hey, Miss Caldwell, this is a dotted line here. Dotted line. That'll be okay as well. Now remember, since it's an inequality, I got to test the point. So let's go ahead and test the point. And since this line does not land on 0, 0, I'm going to test the point 0, 0. That's always the best line to test. And I'll plug it into my inequality. So I'll get 5 times 0 plus 2 multiplied by 0 is greater than negative 8. See if I get a true or false solution. And that will let me know which side to shade. So the 5 multiplied by 0, 0 is 0. 2 multiplied by 0 is 0. And I have 0 greater than negative 8. Is 0 greater than negative 8? This is a true solution. And since it is a true solution or true statement, I'm going to go ahead and shade that side, which is the side that has a 0, 0 on it. And now this is my solution. Remember, any point on the shaded side is going to represent the solution to the inequality. Any point. I could plug in any one of these points that I'm making with the black dots, and it will be a solution to the inequality. Any point on the other side over here that's not shaded is not a solution to the inequality. So all these points are not solutions to the inequality given to us. Now I'd like you to create your own. Come up with your own example. Make sure you put it in slope-intercept form, or you could make it a little bit more difficult, put it in standard form. Graph it, and then give me one point that is a solution and one point that is not the solution. Bring this in to me, show it to me, and I will give you some extra credit points for doing the example. Good luck.